Hey everybody. Okay, so today we're back with some more hackerrank. However, this time we're going to do it a little different. So last time, I personally going back and watching the video, I felt it was a little rushed, and I feel like there's more benefit to slowing down and going through the fewer of these questions, providing you guys more insight into the actual problem, right? So you understand the concept instead of me just kind of knocking out the solution. I tried to kind of walk through how I thought about the questions, but I think we need to go into more detail. And also, what we're going to do is we're going to go into these fresh together, right? So what I've done is I've just came in here this morning, opened up two tabs of data structures to focus on, left rotation and sparse arrays. Those are the name of the questions, and we're going to go through them together. Instead of me kind of going through doing them before and then coming back and showing you guys the solution. Now, if you guys prefer to just me, kind of giving you the solution and you guys kind of working through the concepts, let me know. I mean, we can do that, but I think this way will be a little bit better. So we're going to focus on two, try to get through two. I'm going to pay more attention to the time, and yeah, we'll work through them together and we'll see how it goes. Okay, so let's get started. So this left rotation. So a left rotation operation on a circular array shifts each of the array's elements one unit to the left. The elements that fall off to the left reappear on the right. Given an integer d, rotate the array that many steps to the left and return the result. Okay, this is a pretty standard problem. If you've got a CS background, math background, you've probably done this. Okay, so int d is the amount to rotate by, the array to that's the array to rotate, and then you have a rotated array. You've got some constraints. Yeah, so yeah. So if you'll see here, they kind of go into a little bit more of an explanation, right? So if you got 1, 2, 3, 4, 5, 4 rotations left. So when you rotate this once, what this is doing is this is taking the element on the left and basically moving it. So think about it, right? You're rotating left. So you're going like this, right? So 1 comes in the last element, right? And if you rotate it twice, you get 2 in the last element, then 3, 4, right? It just rotates, okay? So let's do this. All right, so okay, so first thing, so I'm going to switch this to Vim mode. Okay, now, so we need to, and so what I like to do, guys, what I'm doing here is kind of writing the question out in plain language, and then we can go and map our code to it, right? So it looks like it's returning a vector. So what we need to do is the first thing we need to do is all right, we need to check if the array is empty, and if it is, we need to return a vector. Okay, so that's the first thing. So that would be right. So that we need that. Now, okay, so you see where it says D, that's the amount to rotate by. So this means we need to use some modular arithmetic. So so after we test that, we need to capture the length of the array has a U size, right? That way we can use it in the modular arithmetic to define our boundaries, okay? So we will capture length has U size, then we will use that in our we will use that for our modular arithmetic to set our rotation bounds. Okay, so that would look, so what we need to do, we can say let n equals array length has u size. Okay, then what we do is we can say, I'll bump this up one for y'all. Then what we can do, we'll say, we'll just call this k, and then what we can do is, so d, remember right here, d is the amount to rotate by. So what we can do is we'll say d has u size modulo n, right? And that'll create our loop, our bounds, if you will. Not our loop, our bounds. All right. Now, so Rust has a rotate left method, right? So we can use that, and you would rotate that by k, right? It only works. Yeah. So what we need to do, and then so what we'll do is we will capture. So first thing we need to do, right? So we'll need to capture. Numbers are all offed. So we need to capture the array and turn it into a vector, right? So we can use 2vec for that, right? This one, and then we should be able to rotate. We should be able to rotate that that many times. Okay, so we'll just call this v, and we'll say array dot 2vec, and then we'll say v dot rotate left k. And then we should just be able to, I think, return the rotated array, the rotated vector. Right? Which will look like this. Okay. So, well, first let's see if it works. Let's see if it works. Okay, yeah. It worked. See that? Okay, so, and it rotated, so we see 5 is at the beginning now. Okay, so let's go back through. Okay, so, yeah, not here. Okay, so what we did was we checked if the array was empty. We return a new vector if it is. We capture the length of the the array vector if it's empty. Then we capture the length of the array has a u size to use it in our bounds, and then right here, right, we're defining d to be the type to rotate by using modular arithmetic, the modulus, and then we're turning the array into a vector to be able to utilize rotate left, and then we rotate it by well, d, but here, you know, that's k for us because we've did the arithmetic here. Okay, cool. So we are at 9 minutes. I think I want to stop here. I think I want to stop here before we go on to the next one. I want to keep my videos between 10 and 15 minutes long. So I think that it's going to, with the next question, I don't know what it's going to be, but it may be difficult. So what I'm going to do is start a new video. So it looks like we're going to have 2 new videos today. So I'm going to create a new video, and yeah, we'll go through the next data structure there. So if you have any questions about this one, let me know. Shoot me a DM. help each other out in the comments, ask respectable questions, get respectable answers, and I'll see you in this next one. All right, y'all.